All right, welcome. Chapter 12, An Introduction to Database Programming. So what Chapter 12 talks about, we'll get this guy running, is it's an intro to relational databases. So if you already know about relational databases, you could probably skip this chapter. If not, it's a good intro to it. So I'll go through it, rather quickly. This is a recording, so you feel free to rewind and watch as much as you like. And plus, I'm really just going over everything in the book. But if you have any questions, while you're watching this, please pause and send me an email or use the Q&A in the meeting to let me know what questions you might have. So, what do they go over in this chapter? They explain how tables in relational databases work and how they're organized, how they relate to columns, and how they relate to each other. They describe SQL, so that's important, sequential query language, with the four main data manipulation, DML, data manipulation language commands are select, insert, update, delete. So we talk about those. Sometimes I like to refer to them, and others as well, as the CRUD operations, because you create things or insert stuff, you read things or select stuff, you update things, and you delete things. And it's an easy way to remember that those are the four data manipulation language operations that are critical to any database application. Talk about database views. So that's an insert procedures. Those are cool concepts, database level concepts. We talk about ADO.NET, so ActiveX Data Objects, ADO.NET. That's part of the .NET framework, and those are the classes and objects that have to deal with getting and doing those four operations we just talked about. So there's the dataset object, or class, and I use class and object interchangeably. Obviously, these are all classes, but when you use them, they're instantiated into objects. So there's the data set, there's data table, data adapter, there's a command object and a connection object. So this chapter talks about all those and how they interact. And then we also talk about the idea that ADO.NET is a disconnected data architecture. So this idea that you fetch the data, you operate it, and then you sync back. And with that, there's concurrency issues, and concurrency, they call them exceptions, fancy way of saying an error, and how to deal with it. And some of the ways you can deal with it. There's optimistic concurrency. There's this idea of last in win. So the book talks about the pros and cons of those things. All right, so Chapter 12 jumps into, what is a table in a relational database, and typically it looks like an Excel spreadsheet, right? You've got rows and columns. The columns each have field names, so in this example we've got product ID, name, short description, etc. And then for each row of data, it goes down. So we've got RMO1 at the top, then there's BAT01, etc., etc. I think everyone's pretty familiar with this kind of concept of rows and columns making a table. So relational database uses table. That's the whole idea, is that these tables are related to each other to store the data. Each table is one or more rows or records for a single entry. More about that later, but basically when they say entry, they mean entry into that table, but a record in the sense of a complete record about somebody may involve more than one entry in, or more than one table, I should say. And in fact, later when we talk about object-oriented programming in relationship to relational databases, there's this idea of ORMs, or object relational mapping code, that will take a record about something, say a person, and then map it to the one or more tables that are required to store that record, and that's called object relational mapping. So we'll talk about that later. Each row contains one or more fields, or same thing, columns. Most tables, they don't have to have a primary key, but you typically would have a primary key, and I would recommend always having a primary key. It's rare that I want to, in very rare instances, usually it has to do with write performance, where you really want to you're just dumping data in at such a fast pace that you say, I don't have time for a primary key. Because a primary key does require a little bit of maintenance and upkeep. It's got an index associated with it. But for 99% of the time, your table is going to have a primary key. And what does that do? It uniquely identifies each row in the table. It can also have one or more indexes that, just like the index in the back of a book. If I want to go find a row and there's millions of rows in my table, an index can help me find it more quickly. Just like, I look in the back of the book and then jump to that page. Same thing in relational databases. So what is the relationship between two tables? Generally, it's between the keys, so a primary key and then a foreign key. And in this example, they're showing the category table related to, it looks like, the product table. And so each product has a category. That first one, ARM01, is the props category. And then, what does that mean? You go look up in the props table. Oh, it's well, in this case, it's not much more information. It's just props. But let's take FX, the third one down. BL01 is the FX category. And if you go look it up, you say, oh, it's special effects from the long name. So, typically the way this works is that you don't want to have, if I didn't want to have this related table, I could simply have put, the long name in the products table. But if I had to change special effects to, really special effects, I'd have to update that, for every row in this table. So by storing the information, all this information here, and then just referencing it through an internal key, I can update this one time, and these all still point to that over here, so it doesn't require multiple updates. And that's one of the basic tenets of a relational database. If you want to, I think later they talk about third normal form and the idea of a normalized database, and that's one of the tenets of a normalized database, where you try to organize your database in such a fashion that updates happen one time, and you don't have to have these multiple updates all over the place. So some more concepts. I mentioned that the tables are generally related to each other through their key columns. You can have a foreign key that usually corresponds to a primary key in the related table. The last point there mentions that there's different types of relationships you can have. Probably the most common one is a one-to-many relationship, and that's what we saw if I back up a second. So there's one entry for a category, and it has many related rows in this product table. So that's a one-to-many relationship. You can also have one-to-one relationships. Typically, that's where you've got some information about somebody. Maybe you have a person table with some information about the person, and then I have an employee table that's more information about the person if they happen to be an employee. So that would be like a one-to-one relationship, because each person they either are an employee or they're not. But if they are, then there's not multiple records. You wouldn't have multiple records in an employee table that's related to a person table. You would just have one record with the additional information. That's a one-to-one relationship. And then there's many-to-many, and that's typically a good example of that is courses. If you had a course table and then you had a students table, because one student can take many different courses, and one course can have many different students. And generally, the way you implement that is the way you implement a many relationship is you actually have three tables. You would have a course table, a student table, and then a table in between that would store which course and which student is taking it, and then you would store that in a third table, and that's how you would implement a many-to-many relationship. If we're actually using, there's a couple different tools. There's actually a SQL editor in Visual Studio, and this is the design view for a products table where I'm adding different columns to my products table. And when you use the SQL design view, the data types change. So typically, if we're in the C# world, and we have we could have an integer that would represent obviously an integer, or an int, I should say. Integer is the keyword in C#. In SQL, it's actually int. So that's, there's some differences in the data types. They're not the same. So, instead in C# I might have string. In SQL world, it's varchar for variable character, and this goes up to 50 characters. This one's up to 200 characters. So you have to remember that when you even though you're in Visual Studio, and I'll switch out to Visual Studio for a second to show you where this lives. So I'll go to my view and go to my and there's a couple different ways to get to this. I'll go to SQL Object Explorer and try to open up my my designer for SQL tables. So go in there and connect to SQL, do a refresh, and it looks like I don't have my SQL running yet. So let me go add. Oh no, there it is. Okay. So let's open that guy up. So you can see I'm connected to my local SQL. My project database, local DB. Let's see if I don't have any databases yet. So these are just the system. I don't have any user databases yet. These are just the system databases. But if I open up, say, the master table, I can go see some tables in there. These are all system tables. You have to have system admin or SA privileges to be able to get to this kind of stuff, which I do on my local machine. If I wanted to add a table, let's add or a database. Let me add a user database. Right click on databases, add new database. We'll call this DSA. That's the name of my company. So maybe I'm going to track employees and managers and things like that. And then from there, I'll open up and say, hey, I've got an employee table. And actually, maybe I'll have a person table, and then I'd have two more tables, an employee table and maybe a manager table. So this, I'm kind of glossing over this, but this whole database design, it's a whole world unto itself. I mean, there's multiple 5-day classes on this. When I say 5-day classes, I'm talking about Microsoft offers these, what they call Microsoft Official Curriculum. And I'm a quick side note, I think I mentioned it before, Microsoft Certified Trainer. So they have all these, you could spend a career on this database design. So with that, I'm going to spend just a couple minutes and do a quick table design. I have a bit of a process that I follow, or a convention that I follow when I name my tables, and different people have different conventions, but I typically leave in a primary key. I typically make it an integer unless there's some requirements that require it to be some other data type. I typically will call the ID the name of the table followed by the letters ID. So let's call this person ID, because this is going to be my person's table. And then it'll have like a first name, and that'll be a varchar, and maybe a last name. We'll try to keep it really simple at this stage. Now this allow nulls, so whether this field is required or not, maybe I'm just starting out, so I'll go make everything required. Maybe I'll have an age that's not required. Or actually, I should probably have a birth date, right? And then I'll just calculate the age. So make that a date variable. And we'll let that to be optional. So let's save that. We'll call this persons. And again, some people like to have S in their table name. Some people don't. It's really I generally, if I'm working on an existing project, I'll just adhere to the convention that's already in place. If I'm doing a new project, I like to have the S. So we've got our person table. I thought I saved it. I hit save again. No. Now I didn't. So I saved the definition of the table, but I didn't actually execute it against the SQL Server, so it hasn't showed up in my tables in my SQL Server database. Let me go back and bring that guy back out. Where did I save it at? I should have been paying attention. All right, that's right. We'll just do it again. Because what I meant to do is not only save it, but also execute it against SQL Server so that it would then be existing in my database. So it is a two-step process. And we said birth date. It's not case, well, I was about to say that SQL Server is not case sensitive, and that's not 100% true. SQL Server, by default, is not case sensitive. You can set what's called a coalition to make it case sensitive, but out of the box, the defaults are not case sensitive. So it doesn't really matter that I'm making these Ds, at this point, because of I'm actually set for case insensitivity. All right. Let's push that against. That's what this update does. I'm saying, hey, go send this. Basically, what it's doing is preparing a SQL create statement to go, and you can see well, this is not exactly. This is the type of. But if I generate the script, I'll actually see the SQL statement that is going to execute against my SQL database. And if I wanted to, I could actually save this and then email it off or send it off to my DBA if that was a need. But I'm just going to actually push it against my local database. So I'm just going to click update database and now see what happens over there. Push it. Oh, and look, I forgot to rename it. So let me go rename that. And I could have saw that down here, right, in the create table. So I should have been paying attention. Let me rename that. But it's easy enough to change. I want that to be persons. Because I have it open, of course. Let's close it. Do it. Now we have a person's table. All right, and so there's the column. So all that just to show you the designer view that they were showing in the slide. So there, again, is the designer view of an existing table. Now if I decide that I want to add something else, maybe, I don't know. This is not the employee table, but if I wanted a date of hire or something like that, I can make modifications here and then update. All right. So I mentioned some of the SQL Server data types: bit, character, var, and you'll hear some people say car, character, char, varchar, different pronunciations, whatever. It means string data. Text. So there's two things I'll point out here: the text data type and the image. Where's image at? They don't have it on here, but there's also an image data type. Those are both tricky in that they're not really, especially text. It looks like they've grouped it up here with string. It's not string. It's actually what they call a blob, a binary large object, and images is the same thing. And they're used for storing things like Word docs and images and anything that's going to be, large amount of data. You could actually store text up in a text field or in an image field, but it's not meant for that, right? If I'm just storing first name, last name, I wouldn't use the text data type in SQL because it holds up to 2 gigabytes, so it'd be a complete waste of space. Typically, I'm using varchar or char for fixed characters, varchar for variable length data. Text and image are reserved for large, binary large objects. Date, time. The rest of these, I think, are pretty straightforward. So, if you have questions, feel free to pause the video and enter a question in the Q&A panel in the live meeting. These are some of the tables that make up the Halloween database, the example database from the book. So, I like this chart very much. It's a database diagram, simple. You can see the relationships between the tables. So, you've got, products is a one-to-many. The little infinity sign is one-to-many line items. Invoices is one-to-many to the line items, etc., etc. The key represents the key, the table that has the key. And notice most of these have a single primary key, except for line items. They've chosen to use 2 columns to uniquely represent each line item. So they combine the invoice number with the product ID to be and that's fine. You can have multiple columns to do that. However, I will say that I do not do that. It's just a preference of mine. I found it much easier what I would do in this case, if I had to quote unquote fix this database diagram, I would add a line items ID in this table and make that the primary key. And then this would be an alternate key, these two. And the reason I would do that is for maintenance purposes. I don't know how many times someone said, hey, there's a row of data missing, and it makes it much easier to go back through backups and do some comparisons if you have what they call a surrogate key, which is a non-natural key. So having that line item ID, which would be the surrogate key, makes it easier to do comparisons and things like that. Product ID is what I would go with, category ID. This I would, obviously I would call it state ID. Customer ID. So I'm not a fan of using natural keys. I like to use surrogate keys. The next few slides talk about some of the SQL statements. So this is a select statement where you select one or more columns. The brackets mean it's optional to have additional columns. They're separated by commas from whatever table that you're joining. And you can have multiple tables. You can have what's called join statements. You can do inner joins and outer joins and left outer joins and right outer joins. You can have a where clause, that's optional, where ID is equal to 5, where total is greater than 300. And you can have order by, so ascending, which is the default, or descending, which column that you're going to sort by. You can have multiple sorting of different columns. So here's an example of a select statement that grabs 3 columns from the products table, but only where the category ID is props, and we're sorting by unit price. And this is the result. Whoops. This is an example of joining 2 tables, so you would use the join. You don't need to use the keyword inner, the SQL keyword inner. It's optional, and I generally leave it out. It's assumed if you don't put it in there, but you can put it in there. And then when you join them, they don't have to be an equality join. Most of my joins are equality, so I join product ID from this table is equal to product ID from that table. But there are certain cases, rare cases, where you want to do inequality joins. But most of the time, I want to say 97% of the time, it's an equality join. And again, you can have the where and the order by. This is an example where we're saying we need data from two tables, the products table, but joined to the categories table because we want to show the short name, which comes from the category table, and then the product ID, name, and unit price from the products table. So that's a great example why you would want to join two related tables, because you want to show in sort of a report-like fashion some of the additional information from the related table. And that's an example of that result set from that previous SQL statement. An insert statement, so I'm actually putting rows in. You have your insert statement, you have an optional into keyword, the name of the table that you're inserting into, a list of columns that you're going to fill in, and then the value that's going into each of those columns. So this is sort of a mapping going on here where you say, I'm going to insert data into the category ID, the short name, and the long name, and then I have to match that order. So food is going to map to category ID, spooky food is going to map to short name, and then this long, the very best in Halloween cuisine is going to match to long name. So these three values map in the same order of the insert statement. The update statement works similar in that you have update, the name of the table, and then you set different columns equal to different expressions. And you don't have to update the whole row, the whole table. You can say only on certain rows. And typically you would have a where statement. Typically, even though it's showing as optional, it's rare that I'm doing an update on everything. I generally want to be careful of that. I had a situation once where one of my developers updated everyone's password to password, which was not good, so we had to undo that. This is an example of an actual update statement. So we're updating categories. We're going to set the short name to Halloween cuisine, where the ID is equal to food. So that would update a single row. Delete statement, again, delete, optional from, the name of the table, and then again, it's optional where clause, but 99% of the time I've got a where clause. I don't ever, unless I'm clearing out a table. And actually, so a quick side note, if you ever want to empty out a table, delete's not the best way to do it. You probably want to truncate. The reason being that a delete, if say I had a table with 1 million rows and I did a delete, it's going to log, there's a transaction log in SQL, and if I do a delete star or a delete from categories, every row is going to then be logged to my transaction log, which would take a lot of time if it was millions of rows. So instead of a delete, I would do a truncate, which would just log the pages and not every single individual row. So just kind of side tip there. And I said truncate. I meant to say drop. Sorry about that. Truncate is what you do to the log when it fills up and you want to clean it out. A statement that creates a view from customer. So this is an example of a view, and basically what a view is, it's a stored query is all it is. So, if I always want to see last name, first name, state, and email, I can, I could just run the select statement, but I can create a view, so using these keywords, give it a name, say as, and then the definition of view, and that way later I can say select star from customers min, and it knows it's looking for those 4 columns from customers. So in fact, the next slide, it shows us that. So here we're getting all the columns from customers min, only but where the state is CA, and then ordering by last name, first name. And that's the, they're calling it a virtual table. That's the result set of this statement. It doesn't actually, when you create this view, it doesn't actually, it just creates the definition of the select statement. It doesn't actually create a virtual table unless you index the view. In SQL, you can actually index a view, and then it will actually create a virtual table. So that's a good, another side note. For performance reasons, if you ever say, you know what, I want to use up some more space, that's the trade-off. So you index a view, and then it takes up more disk space, but it also means that a statement like that will run much faster. All right. A stored procedure is like a view, except it can do a little bit more. It doesn't have to do just a select statement. It can, but it can also do inserts, updates, and deletes. So in this example, it's just doing a select statement. It's taking a parameter called state. The data type of the parameter is char, and then it's using that in the select statement. and then there's a result set. So how do we execute that? They don't show us, but basically you use an execute statement, exec in SQL, if you want to execute that stored procedure. And we'll talk later about some ways you can execute stored procedures using .NET code and .NET classes. These are some of the basic ADO.NET objects in ADO.NET. So we mentioned these early on. You've got your data set, which is an in-memory mini database. So it can have one or more tables. The tables can have relationships. The tables have columns, but it's in memory. Basically, what you do is you create a data set in your code, and then you fill it with data from SQL Server. And in fact, that's what this chart is trying to show us, that a data set gets these data tables. How does it fill them? You use a data adapter to execute commands and connections to pull data from the database. I keep saying SQL Server, but it could be Oracle or Access or Excel or any kind of data source. That data comes back and then gets stored here in memory on your web server, or because we're writing web applications, but we were writing Windows, sort of fat clients, this could be just the application itself. But it pulls the data using these different objects. What are the other objects? A data adapter is a combination of commands and connections. A command is, holds SQL select statements or insert statements or update statements or delete statements. A connection stores your connection string, so it knows what's the server name, what the username and password is, that kind of stuff. If two users are working on the same copy of data, you can have concurrency issues. So you have to deal with that. Whoops. What do? You have to implement something called concurrency control, and there's optimistic concurrency, there's pessimistic concurrency. There's things like checking to see. You can actually write code that says, "Hey, did the value go grab the category name, and now I'm going to change it." But right before you send your update, you say, "Hey, is it still the same?" Before if it's been changed, then you have to go back to the user and say, "There's been a conflict. What do you want to do?" And then you usually present them with both. Here's what it was. Here's what it is now. Maybe someone made the same change that you're already making, so you just ignore it. Maybe someone made it something different. You want to overwrite it. A lot of times, what people will do, it's just an easy thing to implement, but not really the best thing to do, is implement what's called last in wins, in which basically what you do is you say, I'm the latest update, so I don't care. I went to update the data. If someone jumped in after me, I don't care, and I just put my update in. I'm the last one. Easy to implement, but the problem is that then you have you lost updates where someone makes an update and gets overridden by yours, and they didn't even realize it. So not the best concurrency implementation, but certainly the easiest to implement. We already kind of went through all. The .NET data provider. So in ADO.NET, there is different .NET data providers. So there's one for SQL, one for Oracle, one for something called ODBC, for Object Database Connectivity. It's an older, it's used for connecting to Access and Excel and some older data stores. There's OLADB, Object Linking and Embedding DB. It's a newer version of ODBC, but again, it's used to sort of access different data stores that don't have what's called a native .NET data provider. So SQL Client is the native SQL .NET data provider. There's a native Oracle .NET data provider. And basically what they do is they store the classes necessary to create data readers, which execute select statements, command objects, connection objects, insert update, all the information necessary to talk to the different database servers out there. And later we'll see we'll actually see the SQL Client .NET data provider in action and see some of these objects in code. All right, so that was Chapter 12. Quick introduction to database programming. Hopefully it made some sense. Again, any questions, feel free to go to live media and put out a question, and I'll hopefully answer it for you. Thanks.